So in this video, we're going to talk about the concept of autoboxing and unboxing. So to start with, we're just going to have a brief recap of arrays and array lists, and we'll move on to autoboxing. So firstly, you're aware that we can do something like this, no doubt, because we've actually been through this in the code. Creating a regular array, let's just call that string array, equals new string 10. And likewise, we could do that for an integer if we wanted to. New int 10. So that's creating an array. We've seen that before of 10 elements starting from position or element 0 through 9. And we can also create an array list. We can do an array list string. You've seen this before. And we'll call that string array list equals new array list like so. And we can use that, and then we can do something like string array list dot add Tim, and that would add an element to the array list, and it would actually add an object of a type string to the array list for us automatically. But interestingly enough, what we can't do is something like this. We can't do array list int array list equals new array list. We actually get an error, and the error we actually get is type argument cannot be of primitive type. And this, as it turns out, is an issue because a primitive type is not a class. And we actually need a class reference here to be able to use that to be able to save something to an array list. So if we had a list of integers, we can't save them based on what we know so far of Java in an array list. What we could do, for example, we could do something like this. We could create a class. I'm just going to create it in here. We could put create, we'll do type in class, and we'll call it int class. We could have a private int my value. We could add a constructor, and we could also add a getter and setter. Like so, very simple little class as you can see there. And we could do something like this. So we could just comment this line out for now, and we could do something like array list in class int array list, or int class array list will do for now, equals new int class equals new array list, like so. And then we could do int class array list dot add, and we could do something like new int class 54. And what that would do would be in the first array element in the array list, it would actually add an object of type int class with the value 54. And obviously this would be the class, this would be the class that the object's being created from, that would be added to the array list. So that would work, but it's a little bit messy because there's all this extra constructor code, and there's getters and setters and so forth that we'd need to create to do that. So wouldn't it be good if there was an easier way to do this, and for all the primitive types, the variables, the data types, if there was a way to actually use those as objects? Well, that's what autoboxing is all about, because Java does provide us with that functionality. Now, you might be looking at the string and saying to yourself, well, hang on, string's a primitive type. Why isn't that working? Why is that working, I should say? Well, if you recall, string in fact is not a primitive type. It's actually a class in its own right. And usually you can actually tell that. On the Mac, I'm going to hold down Control and hover over it and click. And you can see that string is actually a class in its own right. It's actually fully a class, and it's got all these other bits and pieces in it. And this is some of the Java source code relating to a class. So that's the reason why that is working. And that is because that's actually a class in its own right. Now, contrasting that to going back to our main again, and if we try and do the same thing to integer, I'm holding down Command on my Mac, and I can't click on that, but I can hover over the string, but I can't over the integer and do anything. I can hover over the integer, but nothing happens when I go to click it or hover, and that's because it isn't a class. So the bottom line is, for the array list, but also for lots of list classes and lots of other Java classes, it needs to be passed a class, in other words, passed an object. So it's very common for you to want to use these primitive types and to be able to pass those as classes. So again, you could do something like this example up here where you could create your own class and pass it, and yes, that will work, but that's not really what we want to do. There's actually a better way of doing that, and we can use the concept of autoboxing. And it turns out that Java supports the primitive types by using a class, an object wrapper, if you will, for the class. Because you can actually think, if you think about it, what we've done here with this class here that we created, we actually created a wrapper. So in other words, we sort of said the integer my value is the variable that's going to contain the value for this class, and we wrapped it up in a class. We made sure that it wasn't publicly available with a variable. We could only update the variable using a constructor initially and then a setter, and you could retrieve the value only by using the getter. So that's sort of the concept of a wrapper, where you're actually wrapping this functionality and the way to access it, the access modifiers, so that not everyone can access it. Well, it turns out that Java's got a lot of these inbuilt. So for example, in the case of integer, we can use something like this. We can put integer, and we can put integer equals new integer. And you can see that the default option for a new integer when we're creating a new object, we can actually pass it into value. So I can do something like that. And the difference between integer and int is that integer is actually a class. So again, if we hover over this, we can see that I can actually click on that, and we get the fact that it's actually a class and all this other stuff relating to how it's set up within Java. So and you'll find that there's one of these for each primitive type. So there's one there for an int, which we've seen is called the integer. There's a double. I'm going to do it. I won't do a couple. I won't do all of them, but the other one's called double. We could call that double value, because I can't use the word double because it's already a keyword, equals new double. And if we hover over it, we can see it's looking for a double value. So we could put something like 12.25, and that will quite happily accept that as a value. So that helps us in the sense that we can now use this in an array list. So we could do something like array list integer. We could call it int array list equals new array list. And you can see now Java is quite happy with that, because this is actually a valid class, unlike what we were trying to do up here earlier when we were trying to actually assign a primitive type into it. So let's just use that as an example just to see actually how it works. Let's now we've created our integer class, let's just do a for loop and actually add some entries. So a typical way to add them would be something like for int I equals 0, I less than or equal to 10, I plus plus. We could put int array list, int array list dot add. And noticing here that it's wanting an integer now, this is the one we're going to select. The integer is the type for this variable int array list. So we're going to add, and we could do something like integer dot value of I. And what the dot value of is actually taking the value of I as the primitive type and converting it automatically into the integer class, I should say, so that we can use it as a class. And therefore, then when we come through and actually execute this, we can do something like, so we'll just copy that code. And need that first line, and we'll do something like I plus, let's just output the contents, and it will be int array list dot get the element that we want to retrieve, and dot int value. So notice there's an int value, which is a value which converts it back from the integer class back into an int type, to a primitive type again, and that's how we convert it. So essentially the two parts that we're dealing with here is this part here. This is autoboxing. This is when we're creating or converting an integer, a base primitive type int, to an integer. That's called autoboxing. So we're taking the primitive type and we're going to the object wrapper. We're going to the class. That's called autoboxing. Unboxing is where we're taking it from the class or from the object wrapper and converting it back to a primitive type. So that's the difference between autoboxing and unboxing. So looking at that code, you can see that it's pretty straightforward. And if we run that, we should find that we get the results that we think we'll get. We should just get the output to show that those integers have been saved. And we can see we get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, as we would expect based on the code we've developed. So nothing particularly hard there, but it turns out that Java actually even makes things easy for you. I wanted to show you the long way of doing it first, and now I want to show you the short way, because it turns out that it's actually easier than you think to create some code to convert to using this autoboxing and unboxing. So for example, what we can do is something like this: integer, my int value, equals 56. So looking at that, you'd probably think, well, hang on, why is that working? Because surely that's incorrect, because we haven't got the reference that we had up here, integer equals new. So when we're creating a new class, we would normally have to use the new keyword and then the name of the class and then pass in the parameters for the constructor. Well, it turns out that Java is helping you out here by issuing a bit of a shortcut. So when you actually type that command in, what happens is when the code is compiled, this code will be executed. So it'll be integer.value of 56. I think I typed. So that's what would happen at compile time. So you can type it like this, but at compile time, it gets converted to that. So in other words, Java is doing the hard work for you because it recognizes and it says, okay, well, this is an integer object. So this is a class and you've entered an integer here. So therefore I know what to do with it. I'm going to actually use this reference here to actually create the proper class based on that, the proper object, in this case, my int value. Now, if you type something like 56.56, that's different because you've now typed a double, and it's actually going to say, it's actually saying to you there, it's looking for an integer, and you've typed in a double. To get that to work, you'd actually have to use a double class, the object wrapper double, to get that to work. And the other thing I want to show you also is, if I just go back to make that valid again, we can then type int my int equals my int value. And again, looking at that, you'd say, well, hang on, this is a primitive type and this is an object. How is that working? Well, what's actually happening is Java is actually doing something like this. It's actually putting integer, it's actually putting my int value. It's putting that code in for us automatically. So in other words, if we put that code, copy that, and we paste that in there, that's essentially what it's actually doing. And oops, that was meant to be my int value. So that's actually what it's doing. Let's fix that up. So basically it's looking at my int value and saying, well, that's an integer, an object wrapper, and it's actually putting the .int value. And if we have a look at the method.int value, you can see that returns an int. So that's why that's working for us. So this is the concept of auto-boxing and unboxing, and you can see that Java is trying to make things easier for you by actually, at compile time, changing the code that you're typing to what the correct code is for it to work, and preventing compile time errors to come up, and really just sort of generating some of the code for you. So it's important to understand though what's happening behind the scenes, because otherwise you'll look at the code and think, well, this makes no sense at all. So there's nothing stopping you from doing things the long way, doing something like that, perhaps to create a new double, or to use, in the case that I showed you up here, we can actually type integer.value of 56. You can type it like that. That would certainly work as well. But it's probably, with these days, with the modern compilers, it's best to actually use it this way because it's less code, it's easier to read, and just makes a lot of sense. So let's just to show you that this works, instead of using integers, because we've used those a lot in previous examples, let's do something with a double type just so it makes sense in a loop. So we could put something like 4. Actually, what we'll do first is we'll create an array list. So it's array list double. We'll put my double values equals new array list of double values. Then we're going to put something like 4 double. We'll call it DBL, our variable. Double equals, we'll start on 0.0. Then we'll put something like, while double is less than or equal to 10.0. Again, we're putting the decimal points because it's a double. We want to increment double. We're going to put plus equals 0.5. So we're going to increment it by 0.5 each time we go through the loop, starting at 0.0 until we get to 10.0. So with auto-boxing, we can type the name of the array. So it's my double values dot add. Then we can put double dot value of DBL, and that would certainly work. And then we could actually use that loop again. What we'll do is we'll do a different loop this time. We'll actually iterate through the array, the entire array. So we'll use an integer this time, I equals 0, I less than, and it's going to be my double values dot size, I plus plus. And we're going to put double value equals my double values dot get I dot, this time it's going to be dot double value because we're converting to a double, and you can see on the right over here it's actually going to be returning a double, so that's correct. So that's going to return that as a double, and then we can actually print that out. So we could put something like I plus value. So that's one way of doing it. So the first example, double dot value of, that's autoboxing. We're converting the primitive type double to the object wrapper, to the object in other words, that's autoboxing. And here we're using the dot double value. So we're actually unboxing, we're converting it from the object wrapper back into the primitive type of, in this case, the double, which is value. So let's just run that, make sure it works. Then we'll just do the shortcuts to this code again. And I've got a typo here. Oops, that should have been I plus, like that. And we'll just try running that again. Okay, so that's better. And what I might do, just to make things a little bit easy to read, let's just get rid of those from the output so that we don't see that in the output, and run it again. And there's our example. Starting from 0, we've incremented by 5 each time, 0.5, 1, 1.5, right through to 10, and there's 20 elements. So again, that's the autoboxing and unboxing. But equally, as I mentioned, we can also use the shortcut. So the shortcut would actually be to remove this altogether and just add double. And likewise for this, we could do the same thing. We could actually get rid of this dot double value if we wanted to, and the code will still compile and run. And the reason that's running is behind the scenes, Java is actually adding those commands using the dot value of and the dot, in this case, double value, to actually retrieve those values back and convert them for us automatically. So that's autoboxing and unboxing. Good concept to understand when you need to actually store common primitive types, primitive data types that are part of Java in array lists, or pass them as parameters, using objects, especially to some other Java code that's out there these days that will actually require you to use these. So they are used quite a bit, the object wrapper equivalents for the primitive types, so it's certainly good to know those. And just in finishing off, as I mentioned, there's one of these for each primitive type, so you can probably find those easily enough. So I'm going to end the video here. In the next video, I'm going to show you the challenge for this part of the course, and type that out, and then you can have a go at that. So I'll see you in that next video.